Strategy number 3 has to do with the different type of problem that you would encounter, and this would be what we call a complex fraction. Complex meaning fractions on fractions, not meaning imaginary numbers, right? So we have basically fractions on fractions on fractions. And if you want to make this look even more complicated, you could, and I'm going to, just so we can be consistent and have a fraction in every term. We'll put 2 over 1 and t over 1, okay? Just because. So I need a common denominator. This is the best strategy I have for doing this. This was shown to me years ago by one of my colleagues at the time. And basically you need to multiply through by the common denominator of every denominator. So my denominators are 2, t, and 1 and 1. Okay, so the 1's not going to change anything in terms of a common denominator. But my common denominator among 2 and t and 1 is 2t. So we're going to multiply every single term by 2t. And when I do, it's going to wipe out some of the fractions. And then we're going to be left with one big fraction rather than a fraction plus a fraction over a fraction plus a fraction, and it just wipes out fractions. You don't have to do it that way. There's another strategy, but it involves finding this common denominator and that common denominator and then multiplying by the reciprocal. And it works, and it's great, and it's beautiful, but let's just grab a red pen and multiply every fraction by 2t. So you get multiplied by 2t, multiplied by 2t, you get multiplied by 2t, and you get multiplied by 2t. And then I'm going to grab a green marker, and I'm going to cancel out anything that I can, and that's going to help me reduce all my fractions. So cancel out the 2's here, cancel out the t's here, and cancel out nothing here and nothing here. They don't cancel out when they're sitting like that. So the next step is going to say the limit as x approaches, well, I didn't even say what x approaches, did I? X approaches -2, which is why we couldn't have plugged in -2 from the beginning, and I said x when I have t's. But you know what? I'm just going to go for it. I'm not going to start this video over just because I had the wrong variable. That is a major thing to do, though. You do need to fix that if you made the same mistake as me. So lesson learned. Be consistent with your variables, and finish writing the problem down before you start your video, if you're ever making a video. So we have just wiped out all the fractions. Let's kind of show what's happening here. And again, we could not plug in a -2 for t from the very beginning. We would have been dividing by 0. But in the denominator, we have 2t times 2. Well, that would just be, well, 4t. And here we have t times 2t, and that is 2t squared. And numerator here is, well, just t times 1, so t. And here it would be just 2. Okay, can we plug a -2 in now? No. All that work, and we still can't do it. Because if you did, you would have -8 here, +8 here, you'd be dividing by 0, you'd have 0 over 0. Yeah, this is where L'Hopital comes in handy, but let's just not. Instead, let's do what we already know to do. This factors at this point. We've got this to a point where it is going to factor very nicely. So t plus 2, numerator, denominator has a common, or greatest common factor of 2t. So that's going to give me 2 plus t. T plus 2 and 2 plus t cancel out because they are the same thing, just in a different order. And so we are now left with the limit as t, not x, approaches -2 equals, or of, 1 over 2t. Okay, well now we can plug a -2 in, right? So we will have 1 over 2 times -2, which is going to give me -4, so -1/4 for that. I'm going to write the next problem. I do recommend you try it on your own, and you can mute the video if you like. And I'm going to try to write it correctly this time. I'm kidding, did it again. We're going to plug in a 0 for x if we can. We can't. We'd be dividing by 0. So let's multiply by the least common denominator of every fraction. My fractions are x over 1, 1 over 1, and 5 over x plus 5. My common denominator is just x plus 5. That's the only denominator I really have. So let's multiply everything by x plus 5, x plus 5, x plus 5. Okay. Cancel what you can, and don't if you can't. Limit as x approaches 0. All right, my denominator is x and x plus 5. My numerator is 5 minus, okay, I might be tempted to say 5 minus 1 times that'd be 5 x plus 5. That's wrong, okay? I see it a lot, even in this level of mathematics, people make that mistake. So just be careful, you're subtracting the whole thing. Just saying. The limit as x approaches 0, 5 minus x minus 5. Feel free to go ahead and do that. Skip this step if you like. And you see what I see. 5 minus 5 is going to cancel. And I am going to write one more step. Feel free to skip this step and jump to the next one if you like. There we go. You stare at that long enough, you'll realize that something cancels, and that something is x. That one's gone and that one's gone. Leaves me with a -1 in the numerator there. So the limit as x approaches 0 of -1 over x plus 5. And now it is totally okay, mathematically okay, to plug in a 0 for x. So we have -1 over 0 plus 5, so we'd have -1/5.